Welcome everyone. In the base catalyzed hydrolysis of esters, our ester can undergo a nucleophilic attack or a nucleophilic addition in step 1. So step 1 of the base catalyzed hydrolysis of esters is nucleophilic addition. In this step, what we need to know, the hydroxide's lone pair of electron is going to attack the carbon center, just direct like that, and the double bond is going to open up. When that happens, we are going to form an intermediate R. I'm going to form R that is having OH. Then I'm going to have OR prime that is having an oxygen. Okay. Lone pair, lone pair, lone pair, the partial negative charge on top of it. Now, when this product is formed, OR prime is going to be eliminated. It is going to happen in a very funny way. We are going to have a situation whereby a lone pair of electron is going to be transferred here, and R is going to be eliminated. So in step 2, elimination of OR prime. When that one happens, we are going to form a new product. And remember, in solution, the OR prime that is lost, we still have it in solution, and it will still help us as the reaction proceeds. So I'm going to have R O prime negative charge. So that one is still going to help us, so we have to take that in consideration as we proceed with the reaction. So in the next stage, the OR being eliminated, I'm going to form R bonded to OH that is bonded to that is bonded to a double bond O lone pair, lone pair. I have a lone pair here, another lone pair here. Now, in this stage, in our step 3, this is where the OR group that left is going to help us. Now, this is what we are going to form. The reaction is still reversible. Now, my OR, the R prime O the minus is going to assist me here in my step 3, and step 3 is going to be deprotonation of carboxylic acid. So remember, I've formed the carboxylic acid in step 2. Then that carboxylic acid is going to be deprotonated. So we call it deprotonation of carboxylic acid. Deprotonation. So the key thing that you have to know in base-catalyzed hydrolysis of esters, the reaction is just a reverse of Fischer esterification. But the key thing that is happening here, the carboxylic acid formed in step 2 during the reaction is deprotonated by an alkoxide. This substance here is called alkoxide. So the alkoxide or hydroxide ion is going to deprotonate that substance back. Then we form a new substance, which is a carboxylate ion, and the reaction is now irreversible. So in step 3, the substance that I'm going to form, let me sketch it very well. Sketch it in a better way. So this is what is going to happen in my step 3. I want you to be careful here. In step 3, I'm going to have a situation whereby the alkoxide is going to deprotonate the carboxylic acid, meaning it is going to pick the hydrogen found on the carboxylic acid, and electron is going to be transferred back to the system, which is our oxygen there. So at the end of the day, I'm going to form R, that is having oxygen that is not bonded to anything. So lone pair, and lone pair. And I'm going to have a situation whereby I'm having oxygen, lone pair, and a lone pair. So this is carboxylate ion. We call this carboxylate ion. But remember, sorry, I did not mention that clearly. Remember, the reaction that we have here is no longer reversible. So it means that the substance that I'm going to form is a direct reaction because it is not reversible. The carboxylate ion I'm forming, so I'm going to form carboxylate ion. The carboxylate ion can reorganize in several ways to form a substance that looks like this R. So this bonded to double bond O and O minus. How is that going to occur? That occurs when a lone pair is shifted to the molecule, and this one opens up. So when that happens, I'm coming to form a substance that looks like this. So either of them, it is still a carboxylate ion. So the key things that you need to know during such a reaction, in the third step, where the deprotonation of the carboxylic acid is occurring, so we say the third step makes base-catalyzed esters irreversible, and the carboxylate ion cannot be attacked by a nucleophile. So this one resists nucleophilic attack. Resist nucleophilic attack. And such reactions are very important. Base-catalyzed hydrolysis of esters is known as saponification. Saponification. And it is a method that is used in the production of soap. We use it in the production of soap using fats. It's a very key type of reaction. Thank you very much. You can have a wonderful time.